Good evening, everybody. Hello, how are you? How are you doing, my 10th board warriors? Well, this is another video from my side. This is the fourth lecture. Previous lectures have been on electricity, two lectures on electricity, and one lecture on human eye. And this is another lecture, magnetic effects of current. This will be divided into 2 to 3 parts. So, this is the first lecture of that. Today, well, this is a very important lecture, guys. Right? See, as the CBSE board are approaching closer, let's say we are almost in the end of January now, right? Just a month to go max. So, this is very important to do revision. And at Diksha Learning Platform, we provide a very good revision platform for you guys. So, hang on with me. You will have an extensive revision, and plus we'll be doing past year problems, important problems. We'll be discussing chapter a lot. We'll be discussing everything in depth. So those who have actually good in this topic, it will be just a revision for them. Hang on with me and learn how to do problems, understand once again, because see, this is a very, sometimes this chapter can be quite confusing. As you already know, sometimes this kind of chapter. Why? Because there is a lot of directions knowing and a lot of things which comes along over here. Well, I'll be explaining everything over here. So kindly please be with me until the end of the lecture. As I said, this will be divided into 2 to 3 parts. So this is the first lecture. I'm just going to present in front of you. So this is magnetic effect of current. Okay, guys, you have done electricity. There we have studied heating effects of current. It means whenever a current passes, where does the current passes? In a conductor. So whenever current passes in a conductor, it has effects. So what are the effects it has? One of the effect is it has a heating effect, which we have done in electricity chapter. So in heating effect, we have done power, we have done heating, we have done all the formulas. Please refer to my electricity lectures for further knowledge about it, to gain knowledge about it. Right now, this is the second effect the current produces is called magnetic effect. Okay, so we will be studying this now, magnetic effects of current. All right, yes, good evening everybody once again, and let's begin the chapter. All right, so this is how it goes. All right, so okay, right, well, this is what we are expecting in this chapter. Okay, so this is the chapter is all about. This entire thing is from your current syllabus of CBSE. You can have you can take a snapshot. Okay, you can pause the, later on when you watch it offline, you can watch this again, take a snapshot of it. So this is magnetic effects of current. All the things written over there are in your syllabus. Anything which is not there, I've removed from there. So this is the latest one we have for your syllabus. Now, what are we going to study in this chapter? These are the main headings. First is Oyster's experiment, which is fairly important for the examination. Okay, magnetic field lines, a very important topic. Question always comes from magnetic field lines, like we'll be discussing what are the properties of it and other stuff. Then we have magnetic field due to current carrying conductor. It means there is a conductor in which the current is going on, and over here we'll be studying how's the magnetic effects because of one current passes through in a conductor. So what kind of conductors we are going to study? 3 types. One is your straight line. Let me just change the color. Red color suits, I guess I came to know that. So straight conductor, okay, circular loop, as solenoid. These 3 things we'll be studying over here. And among that only we will be studying the right hand rule. Okay, so right hand thumb rule, it tells us the direction of magnetic field. See, magnetic field direction is equally important. Okay, you are able to know, okay, there is a current, there is a magnetic field, but direction is equally important. So need to learn that. So be with me, have some patience. Okay, so this is the overview of the chapter. Then we will be studying force on current carrying conductor on a magnetic field. It means that there is a conductor kept in a, the conductor has a current flowing in it. If it is kept in an external magnetic field, it means an outside magnetic field, it experiences certain kind of force. So we'll be studying that. Over there we'll be studying left hand rule, Fleming's left hand rule, and then finally we'll be studying it that when a charged particle moves in a magnetic field, how it behaves. Okay, like electron, proton and neutron, how it behaves in a magnetic field. Okay, and finally we'll be studying domestic electric circuit there is a diagram of it. Okay, we'll be studying that also in depth. I hope this part is absolutely clear. So this is the entire topic is all about. This will be divided into two parts. First lecture is being done today. Second lecture will be soon notified to you. And if something is remaining, we'll cover that in another lecture also. All right. All right. So let's go ahead and start this topic from Oyster's experiment. Okay. So what is Oyster's experiment, guys? What exactly happened with this? See, guys, always I tell you, revision is something very important. It brings the topic in your reflex. So it means that, you know, as soon as you see the question, many a times you might have seen, okay, you have lot, you know, it seems like the paper is quite lengthy. Why? Because you take too much time to solve a problem. By doing revision over and over, your problem solving becomes faster. So you will be able to complete the paper quite fine, quite faster way. So please be with me, revise as many as time possible. Okay. So over here, let's go with Oyster experiment. What is an Oyster experiment? What happened? There was a scientist, Oyster, okay, long back in 18th century somewhere. No need to remember that when it was. But what happened with this guy? This guy was with his students. He passed electric current in a circuit, and he has this needle, that compass. They used to have compass those days, like magnetic compass, because to find direction, there was the only way to find direction was magnetic compass. All right. So they were carrying magnetic compass, and accidentally magnetic compass was kept close to the circuit, very close to the circuit. So as soon as the current is passed in the circuit, it was observed that there was a deflection in magnetic field on this compass. Sorry, not magnetic field, in this compass. So because of that, they found out, this Oyster found out this with this accident, that, you know, moving current and magnetic effect, magnetism had some kind of relation with each other. So what was this relation? That was done later on when so many experiment was done, but this was the first person who came across this through, and this is the experiment. By the way, this is as per NCERT. Over there it is mentioned. If it comes, you just need to make this diagram, keep a compass over here, and just write a small story that when the current was passed through this, then there was a deflection in the magnetic compass observed, and this is how it was done. I hope it's absolutely clear to everybody. I'm moving to the next part. The next part is your, okay. Now, the next part is observing magnetic field and field lines. What is it exactly? So there was a bar magnet which was kept over there. This is again a part from your NCERT ticket. Okay. So there is a bar magnet which was kept over here. So this is a north pole, this is a south pole, and they were iron filling. It means very fine particles of iron. Okay, iron is basically a ferromagnet, right? So iron particles are kept next to it. So it was observed that, you know, by itself, the iron particle, these iron fillings, they align themselves in this direction, which shows that they approximate the direction of magnetic field over here around the magnet, which is like this. And if you see in this way, as you can see, this is my north pole, this is my south pole. So this is how the magnetic lines of force start. So it starts from north pole, goes up to the south pole, and this is closed loop. So what is the meaning closed loop? It means that outside it starts from north, goes to south. Inside the bar magnet, it goes from south to north. So by doing this, it makes an entire loop. This is what happens over here. Yeah. So I hope this is absolutely clear, right? And this one you can see a schematic diagram which shows that, okay, how this thing takes place. So north pole, if you can see, the lines are going over there in south pole. Inside is not being shown over here. Inside is basically from south to north. So from this is the direction from south to north inside. Outside is your north to south, right? I hope this is absolutely clear to everybody. Moving to the next part of it. Yes. All right. So next part over here is magnetic field. Okay. Well, now what is a magnetic field? Magnetic field is defined as area around magnet in which magnetic force can be experienced. It means you take a magnet. Okay. You take a magnet over here. Let's say this is a magnet. Now you take one iron object. It goes, bring it closer, closer, closer. At certain point of time, it will start to attract. So we call that point around this magnet everywhere in 360 degree, everywhere. That point is your field. It's called the field of it. Okay, so we call that area is field, and there's a magnetic effect is felt over there. We call it magnetic field. So it is the area around the magnet in which the magnet force can be experienced by the ferromagnetic materials. Okay, so this is how it works. That's the magnetic field. Now second is magnetic field lines. Now what are magnetic field lines? This is a very important question, guys. These two are very important. So in short answer questions, many a time this question has been asked. So please note down as it is, because this is the exact definition of it. Note down as it is. This is, you have to remember. Okay. And second is your magnetic field lines. So what are magnetic field lines? Magnetic field lines are nothing but these are imaginary lines. Okay, it means they're lines. We know is lines. Okay, we have defined it as a line. Okay, so whenever we plot north to south, this thing and this thing, these are actually imaginary line we draw. For example, over here, let me show you. This is how we show it. So these lines that are being shown, these are basically nothing but imaginary lines. The exact direction is like this because the iron filling came in this way, but these are actually imaginary lines. So imaginary lines, okay, used to represent magnetic field. These are the magnetic field lines definition. Okay. And let me describe the direction of magnetic field force acting on a magnetic substance. Okay, so it shows that how much force will be applied on a ferromagnet or an external magnet when it was kept next to the magnet. Weak force, strong force. For example, over here, as you go away, the distance between magnetic field of line increases, so the force becomes weaker and weaker. Where next to the pole, if you see, the lines are very tightly packed. So here the force experienced by a ferromagnet or magnet will be quite a lot. This is how it works. So this is the meaning of the statement. Okay. All right. So what are the properties of magnetic field lines? Very important question, guys. This is a very important question. These four properties you need to remember, and question will be asked from this question because this chapter has been shortened. Lot of things has been taken out from this chapter. Now so whatever remaining is quite important. So remaining part is this magnetic properties of magnetic field lines. This is a very important topic. Okay, so what happens over here? Let's understand this. There are 4 properties in general we will be studying in this chapter. One is by convention that the field lines emerge from north pole. So it means the magnetic, let's say this is my north pole, this is my south pole. So it is said that the magnetic field lines start from north, goes all the way, goes in the south. So this is the first line. Okay. Second is field lines are closed curves. So it means that when it goes from outside, it goes from, so let's say this is my north, this is my south. So outside goes from north to south, inside is south to north. It completes the one full circle, closed curve. It's not actually circle. Just to explain you, I said circle. These are actually closed loops. Okay. All right. So field lines are closed curves. This is the meaning of it. Or we can also write closed loops. Is the same thing. Okay. Now, third part is field lines are crowded near the pole. It means next to the pole, over here and over here, guys. This question actually has come in PYQ in past year CBSE exam. This question has been asked. This is let's say this is the area near to pole. Here the magnetic field lines will be quite dense, quite crowded. And because of that crowded, dense lines, the force is highest, force is maximum. The strength of the magnetic field over here is maximum next to the poles. This was observed. Okay. So this is the third one. All right. And the fourth one is 2 field lines cannot cross each other. A very important line, guys, also. 2 field lines cannot cross with each other. Okay. So there are 2 field lines. It means, let's say there is one line, there is another line. These 2 lines will be parallel to each other at any given point of time. They will not intersect. They will always be parallel to each other. This is a very important thing to remember. All right. Anyways, all these 4 are quite important. Okay. In which question was asked on this? Question was asked on this in CBSE. All right. These 2 are pretty important. All right. So let's go ahead. Okay. I hope you're enjoying the video. Please keep on commenting the video, keep on liking the video, and come on, Yes, any doubt anybody has? Yeah, all right, let me know. If please write your doubt in the comment box. As we go forward, as we go ahead, we will be able to understand, clarify everything that we can. Okay guys, all right, so next part, let's see. So next part over here is study about bar magnet. Bar magnet is, I would say, the importance wise is a medium kind of importance. Okay, like this was highest important thing, this is the highest importance. Okay, bar magnet is something medium kind of importance. Okay, what kind of medium? But still we can study this. Okay, we can just go through with this. What it says that a bar magnet has two poles, north and south pole. I hope everybody knows that by now, right? And attracts iron and steel particle. I think we have been doing from our childhood, right? We have been seeing from our childhood, magnet attracts iron and steel, right? Okay, like poles repel, we have also seen, when we were kids, we used to take two bar magnets, we used to bring close to each other, north facing north repel each other, north facing south attracts each other. We have done that when we were kids, right? When freely suspending north pole magnet towards the north. So it means this is how the compass is made. Okay, so what happens was that if you take one bar magnet, you suspend it with a small thread. Okay, you will see automatically it will align itself with the earth north and south pole. So this is the basic idea. This is how the compass is made. Okay, the magnetic compass we are talking about. Okay, and they are permanent magnets. So bar magnets are basically permanent magnet. They do not lose their magnetism. Okay, so these are the points, pretty easy ones. There's no need to do any hard work in remembering that, guys, right? So come on, I hope this is absolutely clear to everybody. Let's go, let's move on to the next part. Okay, so what is the next part? All right, so as I said, so we have covered the second part of it. Now we are at the third part of it, magnetic field due to current carrying conductor. Now what is the magnetic field due to current carrying conductor? Now this is where the understanding comes into picture. Okay, this is where the understanding comes. This is how you understand. Okay, so before moving forward, I hope almost everybody would be knowing this by now. Okay, but and in revision I'm going to explain you exactly how this thing works. So this is a right hand thumb rule. So what does this rule says? This rule says that there is a current carrying conductor. Let's say there is a current, there is a conductor. Okay, current is always flowed in a conductor. So when the current is flowing in a conductor, how would the magnetic field looks like? What will be the direction of magnetic field? This is what right hand thumb rule tells us. Okay, so what is, so again let me tell you, let's say this is my conductor and current is going from bottom to up, from here to here is going up. Now what does the rule says? Right hand thumb rule, take your right hand. I know everybody knows what is their right hand is, right? So take your right hand, put your thumb in the direction of current, like this. You can see, put your thumb in the direction of current from bottom to up and curl your fingers. So if you curl your fingers, you can see as you curl your fingers, this will be the direction of magnetic field. This will be the direction of magnetic field. I hope it's absolutely clear, right? So you take your right hand, thumb in the direction of current, curl your fingers, and this curl of your finger gives you the direction of magnetic field. So this is how it looks like. It will, for a straight conductor, it will look like concentric circles. And what are concentric circles? They have same center. They have one center but different radius. So they do not intersect with each other. Concentric circles. I hope everybody knows that. Correct? Now, this is your right hand thumb rule. I hope it is absolutely clear, right? Because this is the backbone of, this is what is asked in exam. And when the question is asked in exam, this is how you exactly have to explain it. Right hand thumb rule is asked in the exam, you should know how to explain it. Where it is used? It is used when a current is flown through a conductor and a magnetic field is produced. That direction of magnetic field is given by right hand thumb rule. Okay, concentric circles. Now let's go ahead. There are three types of things are in your syllabus. One is straight conductor, straight wire, I mean straight wire, just a straight wire. Second is circular wire, and third one is solenoid. Okay, all three are equally important. Okay, solenoid is little bit more important than other two, but all three are equally important. You can't leave any one of it. All right, so let's go understand. Let's go further. So magnetic field due to straight conductor carrying current. Now, as I just said, there is one conductor. If current is produced in this, current is going in this direction. All right, so it means this will be positive, this will be negative. All right, so magnetic field produced, you take your right hand, put your thumb in the direction of conductor, in the direction of current going in the conductor, and curl your finger. So you will see magnetic field would be like this, would be like this. This is how it's going on. It's coming out of the screen and going in the screen, coming out of the screen and going in the screen. This is how it is going on. It's a 3D, guys, 3-dimension. I hope it is absolutely clear to everybody, right? It is 3-dimensional. So it means that it is coming out, going in, coming out, going in, coming out, going in concentric circles. This is very important, guys. Please do mention this thing called concentric circles. Okay, concentric circles. Concentric means same center, circle of same center, different radius. Okay, so they do not intersect with each other, and our magnetic field lines, they do not intersect with each other. So this is your current carrying in a straight conductor. Okay, now in case of circular loop, now what happens in case of circular loop? As you can see, circular loop, the current is going like this in a circular loop. Current is going like this. How would you find out the direction of current? The direction of magnetic field over here is simple. You take the, okay, let me put, yeah, red color is good over here. So at any given point of time, let's say I want to find out what is the direction of magnetic field. So what I do is I plot a tangent to this circular loop. Tangent. Let's say this is the tangent. Now at this tangent, I can see the current is going like this. I hope everybody can see this. Current is going like this. So again, take your right hand, curl it, and you will see this is how the magnetic field going on inside the loop. Okay, same thing goes in this side. You put a tangent, the direction of current is like this at this point of time, at this point of this circular loop, and is going like this. So near to loop, it will be high strength. Okay, as it goes inside, the strength of the magnetic field goes little down, and right at the center, exactly. Guys, there is some technical issue going on with us. Please hang on with us. Anyways, you can watch this lecture in recorded mode also. All right, so I'll be continuing once our internet restores, but once it comes to you, it will be in a seamless process, seamless lecture, so that you can watch it nice way. All right. Okay. All right. Yeah. Again. Okay. All right, guys, we restored everything. I mean, technical glitch, man. I mean, we cannot help everything. Okay, some things are not in our hand, but what's in our hand is to give you good insight of the chapter. This is in our hand, so we are trying our level best. We have our technical person Arun, who's working with us day in and day out for you guys. Trust me. Okay. All right. So come on, let's get back to the lecture. Now, as I said, this is a very small topic compared to any other topic, but you have to understand what is being asked. The most, when I went to many colleges, I taught people, I came across this part. Many people, in fact, 99% of the people, all the persons, okay, I found they had a problem in finding the direction, understanding the direction, because magnetic field is basically 3-dimensional in nature. Sometimes we cannot imagine what's going on. So I will tell you guys, in exam, when question comes, you will remember, let's say you have a paper in front of you, question comes, okay, what is the direction of magnetic field in this? what your job is, take your right hand. Don't be lazy in exam. Don't do in your head. If you do in your head, you will make mistake for sure. Do not do in your head. Take your right hand. Don't be lazy in exam. Just 2 minutes. Take your right hand. Put it on the paper, the direction of current. Let's say CBSE says, okay, 1 second guys, this has gone forward. Okay, so let's say CBSE says, okay, 1 second guys, okay, red color, yeah. CBSE says, let's say this is the direction of current. What will be the direction of magnetic field lines? So your job is take your hand, right hand, put it on the screen, the thumb in the direction of current. Now curl your finger. So as you can see, the field lines will be like this, going inside, coming out, going inside, coming out. So it will be plotted in this way. So going inside, coming out of the screen, going inside, coming out of the screen. I hope it is absolutely clear to everybody. Please do this, guys. Otherwise, you will make mistake. Okay. I have seen a good person who knows this thing still make some kind of mistake. Don't do that. Okay. One very important question is loop. What they ask you in the loop is at the center, the magnetic field is going to be straight line. Okay. In this case, it will be going inside. I hope everybody can imagine over here, right? In this case, it's going to be going inside. So these are the concentric circle. Once again, how do you find it? Plot a tangent on the loop, keep your right hand in the direction of current and curl your finger. That's it. So these two things are, I hope it is absolutely clear. This is where I'm spending a lot of time here, guys, because I know where the problem lies. Where does people have a problem? This is a 3-dimension thing. So lines will be like this, coming out of the board, going inside the board, coming out of the board, going inside. This is how it's going to work out. All right. So let's go with the next topic, next one. And next one is solenoid. So as I said, these three are very important. One of it will come in exam. One of it. Most likely is solenoid, because solenoid is the most important among all three. But second most important is circular loop, third is this. But all three are equally important and easy also. And if you watch this video, I mean, you might have already learned this for sure. All right. Now, magnetic field in solenoid. Okay. Now, how does it work? How does it look like in solenoid? This is exactly, okay. How to find which pole is created where? Okay, we will tell you about that. Okay. Now, as you can see over here, which pole is created over here in solenoid. Okay. Now you see. Okay, Sumuk Hegde, this is good. This is going to be your answer. Please watch it carefully. All right. Now, solenoid. Solenoid, what is a solenoid? So what do we do is we take one copper wire, we just tie up very tightly, too many turns, very tightly, and remove, and it will look like a cylinder. Have you seen spring, guys? That spring, it does look like solenoid, but a lot more turns over there. Okay. So what happens is, this is how the solenoid looks like, as you can see in the screen. Now, let's say the current is going from positive, is going like this, all right. So it's going like this, coming like this, going like this, coming like this. I hope everybody can imagine how the current is going on. So current is going like this current is going. So because of this current, the magnetic field is produced. How to calculate magnetic field direction? Same, right hand. Okay. But over here, what you need to see is inside the solenoid. Inside the solenoid, the magnetic field lines are uniform in one direction. So inside the solenoid, we have uniform magnetic field. This is what happens inside the solenoid. Okay. As we go outside, okay, and we know that magnetic field lines of forces goes from north to south. So wherever the magnetic field of lines coming out, we call that point as north. Wherever is going in the solenoid, we call that south. Solenoid acts as a bar magnet, similar to bar magnet. Inside you have south to north, outside you have loops like this. So inside you have uniform magnetic field, same magnetic field everywhere. Outside, this will act like a pole. So here the magnetic strength is maximum. As you go away from the pole, the strength becomes lower and lower, and again it becomes stronger as the magnetic field lines are tightly packed, as you can see over here. All right. I hope it's absolutely clear to everybody. Okay. So solenoid, this is what happens in solenoid, a very important topic. So what happens with solenoid is, if you what kind of questions are asked? If current is increased, what happens to magnetic field? If current is increased, the magnetic field also increases. Magnetic field increases. Okay. This thing you have to remember. Second thing is, what happens? Okay, what if we increase the number of turns of the solenoid? If number of turns are increased, if number of turns are increased, the magnetic field increased. Magnetic field increases. Okay. I hope it's absolutely clear. So these two things are quite important, guys. Everybody, please make a note. These two things are quite important. What happens when number of turns are increased, and second, what happens when the current in this solenoid is increased? In both the cases, the magnetic field increases. All right. Okay. Yes, Hegde, absolutely right, it increases. Okay. So North Pole, South Pole, this is exactly what you have to plot when it comes in exam. It's a very important question from the examination point of view. Again, I'm telling you, I hope it's absolutely clear to everybody. Please give me a like and thumbs up in the comment box if you like it. Come on, give me a like and thumbs up, please, over there. Everybody. Okay. All right, guys, let's do our next topic. Our next topic is your force on a current carrying conductor. It means, how does, let's say there is one conductor is kept in magnetic field. Okay. How does the force on a current carrying conductor is calculated? Okay. All right. Before that, I want to tell you there is something called Fleming's left hand rule. Now, what is this Fleming's left hand rule? Now, guys, so far we have seen right hand. Now, when we calculate force, we use left hand. I hope everybody identifies their left hand. This is a common mistake everybody makes. Instead of using left hand, they use their right hand. And when they use their right hand, the direction comes opposite and they make a mess out of the question. Please don't do that. Okay. Here what happens is, in left hand rule, we are using the left hand. Remember, left hand is on the left side of your body. So I hope everybody knows that, right? Yeah. Okay. Please don't get confused. It looks pretty obvious. It's pretty common sense. But when I was teaching in class, there's a lot of students. They were thinking, I was telling them, use your left hand. Still they were using your right hand because they are right-handed. They've used their right hand. Please don't make mistake. Okay. So what happens is, take your left hand. Okay. Just do like this. All right. As you can see over here. Okay. Let's see. As you can see. Okay. Let me put over here. This is my thumb, index finger and middle finger. Okay. So what happens is, this, you take these three parts over there as it is shown over there. Okay. The thumb shows you the force. Okay. Finger shows you the field, and the middle finger, okay, the index finger shows the field, the middle finger shows you the current. How do you remember it? There are two ways of remembering it. One is your FBI. So this is your thumb. This is your magnetic field. Okay, magnetic field. Okay, and this is your current. And second way of remembering this is father, mother and current. Okay, father, mother and child. So father, mother and child. So father is your thumb, mother means magnetic field, C means current on your magnet. So there are two ways of remembering it. Whichever, I hope everybody knows it because it's everywhere. This is no secret, guys. Okay, so it's everywhere. This is just a revision class. I know everybody already knows it. If you don't know, now you know. Okay, so your thumb is your F, this is your M, magnetic field, and this is your current. Okay. Okay, father, mother and child. You can see that. Now, how does this thing happens? How does these thing happens? Okay, so let's say there is one conductor which is there is a conductor which has a current. Please understand this. If you understand this, you can understand this experiment very easily. So there is a conductor which is carrying current. Okay. Now what happens is, if there is a magnetic field, let's say we have a magnetic field from left to right. Okay, let me change the color of the magnetic field. All right, so it's going from left to right, magnetic field. Okay, this is our current, red color over here. Okay, this is our current. This is our magnetic field. So where will be the force? The question is, where will be the force? Answer is, take your left hand. Make it like this. All three are perpendicular to each other. Like, take it like this. Now, you come over here. Now, your middle finger in the direction of conductor, right? Yeah, your middle finger in the direction of conductor. So, you take your middle finger in the direction of conductor. Okay, let's put it this way, right? Okay, yeah. So, conductor is going up, field is going like this, all right? And you have, where will be the force over here? Yeah? Come on, tell me in the comment box. Where will be the force? The outside, coming outside or going inside? Yeah? Tell me. Everybody, tell me in the comment box, please. Yeah? So, if you see this is your current, and going this way, the force will be outside, as you can see. Okay, this is the current going on, and force will be outside over there. You can see that very well. If you understand this, you can understand how does the thing work. Okay, now I'm going to explain you this experiment. Okay, all right, let's have this, just have a look of this experiment, guys. So what is this experiment is all about? All right, yeah, okay. All right, just keep on commenting in the comment box, okay? All right. So what happens in this experiment? If you see this experiment, all right. So what happens is, there is a conductor. Just imagine it in a 3D, guys, okay? This is a conductor, okay? This is kept like this. And there is a horseshoe magnet which is kept like this, just around the conductor, okay? Let's say the horseshoe magnet is like this, okay? Just like this, you can imagine, yeah? This is horseshoe magnet is kept like this. When we pass the current through this, now this is the north pole. As you can see, this is the north pole. This is the south pole. So why are we using horseshoe magnet? Why? What is the reason behind that? Because horseshoe magnet has these two poles in the end, and the direction of the magnetic field will be straight from bottom to up. That's why we are using this horseshoe magnet. Now, when the current passes through this, use your Fleming left hand rule, take your left hand, find out where exactly is the force. Over here, the force will be inside. Now, why is it inside? I'll leave it up to you. Please drop me in the comment box, let me know in the comment box. Use your left hand, your middle finger in the direction of current, index finger in the direction of magnetic field, thumb in the direction of force. So if you take it, you will see the force is inside. This is how it is going to work. Okay, all right. So this is how it's going to work. This is the experiment is all about. Okay, guys, let's go further. I hope this experiment is absolutely clear to everybody. Yes, plus drop me in the comment box answer. Okay, did you find it or not? Let's go further. Okay, so now motion of charged particle in magnetic field. This is also a very important topic, guys. Okay, so motion of charged particle in a magnetic field. As I said, we will be taking this chapter into 2 to 3 parts. Okay, so right now we are understanding this chapter, everything about this chapter, and remaining part of it, like previous year problem, important questions, MCQs, case studies, we'll be doing it in our following classes. So please be with us. All right, as of now we are understanding, because this chapter is all about understanding. You understand this chapter, you're done. You will not make mistake. Okay, so now motion of charged particle in a magnetic field. This is also a very important topic. Okay, so we have, let's say there is a magnetic field like this. There is a magnetic field. What happens when a charged particle moves? it experiences a force. Let's say there is one charged particle which moves. Charged particle, remember charged particle, okay? The thing over there is charged particle. When the charged particle moves in a magnetic field, it experiences a force. Again, use your Fleming's left hand rule to find out the force behind that, okay? So, all right. So, over here, you will have, where will be the direction of force in this case? In case of proton, if you use your left hand, you will find the force will be inside. So, inside force is shown as cross, guys. Okay, when it means cross means when something is going inside the board, we show it as cross. When something is coming out of the board, we show it as dot. It means coming out. Where this thing has come? From the arrow. You see an arrow, when the arrow goes in, when you see arrow is going away from you, you will see the cross at the back. When you see arrow coming towards you, you will only see a dot. So this is exactly being shown like this over there, okay? So in this case, if you see, the force will be inside. Force will be inside. Use your Fleming left hand rule and let me know in the comment box, did you get it right or not, okay? So in case of proton, force will be inside, okay? In case of electron, electron always move opposite to what the left hand rule says. This is an important part. So it means if left hand rule says the force is inside, electron will go ulta. Why? Because this is negatively charged. So it will be opposite. Okay, it means it will just go in ulta. Just understand this part. Okay, and neutron, it will experience no force. Why no force? Because it is neutral. It is neutral in charge. So it will, if neutron goes, it will just go. If you have electron, it will just go out, come out and take a circle. If it is proton, it will go in and make another circle in the inside direction. I hope it's absolutely clear to everybody. Right? Give me a thumbs up if you like it, guys. Give me a thumbs up, everybody. Come on, give me a thumbs up if you like this. All right. Thank you very much. Let's go further. Okay, let's go further. You can, if you couldn't follow this, you can watch this later once again, this recording. Go slow, make it 0.75. Go slow, understand every single word of it. You see, as I said, this chapter is small. Okay, this chapter is small. But the question will come from this small chapter. Think about it. Every single thing is important now. All right. So please be with me. All right. And understand it. Go slow, because this may look small, but understanding is quite crucial in this chapter. Why? Because there are a lot of directions involved. Left hand, right hand, this, that going on. So just be with me over here. Let's go further. Let's go further. So now we have, oh right, now we have next thing as domestic circuit. Now what is the domestic circuit? This is the last part of your chapter. This is the last part of your chapter is given as domestic circuit. Okay. Now what is a domestic circuit? Domestic circuit means that how the electricity is coming in our house. Okay. So three things you have to remember over here. This diagram is very important. This can come as a long answer question in your exam. Okay. So you need to be able to plot the diagram over there. So what are the meaning of it? Let's understand it. As you can see, there are three wires: green, red and black. Okay, green, red and black. Now this red color wire is your live wire. The meaning, what is the meaning of live wire? The meaning of live wire is that this is where, okay, let's say there is a power station. From the electricity starts. There is a power station. From there the electricity starts. So electricity comes to our house with this red color wire. Okay, that is called live wire. So live wire, the electricity comes. On live wire, initially there is one fuse is put over there. This fuse is outside your house, guys. Just imagine it, okay? Just imagine with me. The electricity is coming. First, they put a fuse which is outside your house. So what does this fuse does? What is the job of a fuse? Important question, guys. Okay, we'll understand fuse also in a minute. Important job of the fuse is, if there is a high current then this fuse melts, breaks the circuit and stops the current. Okay, this is the job of a fuse. It sacrifices itself. Okay, बोलते हैं ना बलि का बकरा, kind of this is बलि का बकरा. Okay, now next is your, this is your electricity fuse. Now next is your meter. In this meter it is noted that how much electricity has come to you, so that you have to pay a bill, you know. So this is your meter, electricity meter is called. Now after this, then there is a distribution box. There are a lot of switches, there are a lot of this. Okay, and then followed by all the appliances are put in parallel. I hope everybody knows what is parallel from current electricity chapter. All the appliances are put in parallel. In India, we have 220 volt supply. In India, outside there are many countries which supply at 110, like US has 110 volt. In entire country, it depends on country to country. In India, we have 220 volt supply. Okay, so this live wire comes over there. Okay, it passes the electricity in this. Now let's say this is our appliance. This is, let's say, refrigerator. So electricity goes in a refrigerator, but it must make a, as we know, for current we have to have a complete loop. So for that, this neutral wire come into picture. What is the job of this neutral wire? The current goes out from this. Current comes like this, comes over here, and it goes out from here. This is the job of a neutral wire. All right. Now third is earth wire. Now what is the job of earth wire? Earth wire is a very important wire, guys. Why? The job of earth wire is basically, see, what does earth do? It takes all the extra charge from the appliances. It takes away all the extra charge. So what does it do? Earth wire is, let's say during this process the charge is accumulated on our appliances. Have you seen, you go to an appliance, sometimes you touch it and you feel current, right? You touch something, you feel current. So what is happening over there? That appliance is not earth, is not grounded, because you are feeling the current, because the charge which is there accumulated on that appliance, it has remained on the appliance, it is not gone anywhere. So if you touch it, the charge through you goes to the ground and you feel shock, you experience electric shock, right? So avoid that electric shock, to avoid that injury, we use earth wire. Now this earth wire, the job of earth wire is that it takes away extra charge and goes to earth, and it saves you any additional charge which comes. So this is very important diagram, guys. This is a schematic diagram. Okay, so I hope it is absolutely clear what is happening in this domestic circuit. You can have a look, you can take a screenshot. Okay, you can understand it. If you can't understand, you let me know. Okay, let me know in the comment box. I will get back to you. Anyways, we will have another class on this, so I'll personally read all the comments. If you have any doubt, if you have any special request or something, we'll surely take up in the next class. All right, guys, as of now we are just going further and in understanding this part. All right, now, so this is about the domestic circuit. There are a couple of more things which are remaining, guys. Okay, one is overloading, and second one is short circuit. Okay, now what is this? These are two important terms, guys. These are two important terms, overloading and short circuit. Now what is it? Okay, so overloading, let me explain you first overloading. So let's say you have appliance, let's say you have a refrigerator, or let's say you have a TV. Okay, you have a TV. Now you bought a TV in the local store, Chinese TV or something. Okay, now this Chinese TV has some problem. You know, Chinese TV usually have a problem, and we know everybody, right? So this Chinese TV, what it did was that sometime it asked for extra current in the circuit, a lot of current, because of some technical problem in the TV. Let's not go deep into it. Let's understand what is overloading is. So this TV, it demands extra current sometimes. So when the extra current comes in your house, these wires from this live wire, this extra current comes to the appliance. These wires are not able to handle that extra current. Why? Because we see heating effect of current, the wire becomes hot and eventually it catches fire sometimes. So this particular thing is called overloading. I hope it's absolutely clear to everybody, right? So what is overloading? We have an appliance, it asks for extra it takes extra current, and that extra current causes the fire in the live wire. Okay, so that is your overloading. Okay, now what is short circuit then? What is short circuit? So you see, in this diagram I've seen straight line wires and all, but in reality wires are not straight lines. Have you seen, right? You take out any bulb or something, wires are just going here and there, just like that. So what happens over here is, let's say we have one live wire, okay, and let's say we have one neutral wire. Okay, this is our neutral wire, and this is let's say our appliance is over here. Let me just plot it, guys, for you. Let's say we have our TV unit here, and let's say we have another one is, let's say, the blue color. Okay, so this is our neutral wire. Okay, this is from there the current is going out. So what happens is, because wires are too close to each other, these two wires eventually sometimes, not always, sometimes they touch each other. Sometimes they touch each other because wear and tear, you know, the coating on the wire goes away, because, you know, maybe low quality wire or something, maybe after few years when you put it in new, then nothing happens. When after some few years, maybe some rat has, you know, chew something on the wire, so the coating on the wire goes away. Now we have a naked wire. These two wires, when they connect, when they touch each other, so current, which is, okay, let's say this is the current is coming like this. Okay, so the current is coming like this. All right, so the current, instead of going to TV, this current goes in like this, okay, and comes out like this. It takes this route. Okay, let me make this clear to you. Okay, it goes like this, and comes like this, because the current will always go in the lowest resistance possible, or no resistance possible. So if there is very low resistance, we know V is equal to IR, Ohm's law, or R is equal to V by I, or let's say I is equal to V by R, right? Okay, we can take this. Okay, now this formula, I is equal to V by R. If resistance is low, current will be very high. So because of this low current, we have very high current passes through this, and because of that, we have something called short circuit. It can even catch fire at times. You know, in many places, whenever you have electricity fire, 90% of the cases is short circuit. Okay, not because of overload, but it's 90% of the time it is short circuit. Okay, short circuit, this thing happens, overload, extra demand by this thing. Okay, and how to avoid it? How to avoid each of it? So what happens is, for overloading, it is avoided using fuse. Short circuit is also avoided using fuse. So it's the fuse which saves us. Now what is a fuse? What does a fuse does? Let's say there is a fuse. So what does a fuse does? So there is basically a wire inside a fuse. This wire has a low melting point. Conductor with low melting point. Conductor with low melting point. Very important, guys. Exam, you get question in exam, what is a fuse? This is your definition. Okay, conductor with low melting point is your fuse. So when the current comes inside, when the current becomes large enough, it has low melting point, this wire melts and it breaks the circuit, so current cannot go forward because the circuit is broken. Okay, so same thing happens over here. If we have large current over there, in this case, okay, when you have large current over there, the fuse stops, fuse burns and it stops. Even in case of overloading also, whenever there is a large demand of the current, fuse burns and stops over, and stops in the way, and it saves us, saves our appliances, saves the, saves everything. All right, I hope this is absolutely clear to everybody. Everybody would have eventually enjoyed this. Yeah, bye now. Okay, guys. Yeah, come on, give me a like in the comment box, please, everybody. And comment also over there if you like this video. All right, guys. So this is it. Okay, so this was the entire chapter I wanted to take. Okay, so again, go back because we are almost wrapping up this video for today. And in our next class, I will be coming up with lot of MCQs, short answer questions, long answer question, case studies, previous year board problem. In our next class, we'll do everything. So please be with us today. Study what we have done. Very shortly, it will be announced our next class, when will be our next classes, and you will see that in our comments on. So this is a Diksha Learning channel where we are here to help you. So keep on commenting, keep on liking our videos, and so that we can make more and more videos. And please tell us in which topic you want to make us to the video, which topic you want us to make, which topic you find the difficulty in. We'll make videos on that topic. All right, guys. So over here, please understand this part, this magnetic effect of current. This is how you should study entire chapter. This is how you should make the notes of it. So thank you very much. Well, my name is Ravi, and as your master teacher, I'm taking off. I'll see you soon next time. Thank you very much. All right, guys. Thanks for your support and your love. Bye bye. Take care.